So section 3 is going to cover an industry consumption model, which is going to lead right into the next section 4, which talks about the Leontief input-output model, which uses this setup to actually go through and solve a problem. So we're breaking it down, doing one piece at a time. So first off, just a little blurb about what we're doing here. It says the Leontief input-output model was developed by Harvard economist Wassily Leontief in the 1960s. He began his study by constructing input-output tables that describe the flow of goods and services among various sectors or industries of the economy in the United States. So we're going to go through an example of this in order to show you how to set this up. So it says, suppose Power Source buys an electric motor company and begins producing motors as well as batteries. The company's primary reason for this merger is that electric motors are needed to produce batteries. The production requirements for each division are described below. So we're going to have specific requirements for each division, and the actual model is going to be on the left, and then we're going to use this model, which uses these two boxes, to set up a specific matrix that represents the model. So you can transfer from the model to the matrix or the matrix to the model. So we're going to start by taking each division and giving them their own little box. So this is the battery division, and this is the motor division. And they can call it a division, a sector, a department, anything like that. Here they're just calling it a division. So first thing they tell us is that for the battery division to produce 100 batteries, it uses 3% of its own batteries. So this battery division is producing batteries, so they're coming out of the battery division, but then is using 3%. So they're going to loop right back into the battery section. So you can draw like a little arrow there to show the flow of those products. And it's going to use 3% of its own batteries. Now we never use percents in our calculation, so I'm going to go ahead and label this loop with the percent, but as a decimal. So this is going to be a 0.03%. So we're producing batteries, but 3% are going back into that division. They're being consumed by that division. Secondly, here it says for every 100 batteries produced, one motor is required from the motor division. So they didn't give us a percent, but here it's really easy to find our percent because it's 1 out of 100, which gives us 1%. But now, this is not flowing from batteries to batteries. We are taking a motor, which is coming from the motor division, and we're using it in the battery division. So we're taking one motor out of 100 to the battery section. So that's basically 1 out of 100 here is equal to 1%. And again, we don't use the percent. We're going to change it to a decimal. So we are going to go ahead and call that a 0.01 label there. Okay, so then I'm going to continue this flow here and go on to the motor division. So it says for the motor division to produce 100 motors, it must use 4% of its own motors. So the motor division is producing motors. They're coming out, but then they're being consumed by that same department. So I'm going to draw a little arrow there to show what's happening. They're coming out and going right back in. They're being used. That 4% gets changed to a decimal, so 0.04 gets labeled on that loop. And we used that one already. So we're on the last section here. For every 100 motors produced, 8 batteries are required from the battery division. So we're taking batteries from the battery division and using them in the motor division. So that's another 8 out of 100, because they didn't give us a percent here, which is actually 8%, but we're going to use the decimal rather. So their batteries are coming out of the battery department and going into the motor division. And we're going to label that, it says 0.08%. Alright, so this is the model, the consumption model. We're going to change it now to a consumption matrix. So we're going to call this matrix C. I'm going to put that off to the side because I'm going to label it. C is equal to. Alright, so we're going to go ahead and we're going to use these division labels on our matrix. So since there's two divisions, it's going to be a square matrix. It's going to be a 2 by 2 matrix. And I'm going to label batteries, B for batteries, M for motors, and I'm going to go the same order. So batteries was first row, motors was second row, so I'm going to do the same with the columns. Batteries is first column, and motors is second column. Alright, so what we're going to do is we're going to take this model and transfer it into a matrix form. So what's happening here is this side is what's being produced. Ran out of room. And up here, the top is where it's being used. So basically, this is where it's coming from, and this is where it's going to. So basically, from batteries, and we're going to go row then column as always, from batteries to batteries. So I'm going to fill in one at a time. So what's going from batteries to batteries? Well, I know that's that loop. It's coming out of batteries and going back to batteries, so I'm just going to put that 0.03 there. I'm going to go and fill in the column first. Well, here it's coming from motors, but going to batteries. So from motors to batteries is that 0.01. Now I'm going to fill in that second column, so from batteries to motors, so from batteries to motors is 0.08. And lastly, from motors to motors, so that's that loop, from motors back to motors is 0.04. And this is going to be called our consumption matrix.